Hello students, this is the instructions for slides 13 through 17 of the Unit 3 chemistry project. So taking a look here, this last part is just going over polar covalent bonds. So this is going to be how you explain how your nonmetal from slide number 3, again nonmetal from slide number 3, bonds with a hydrogen, all right, which is also a nonmetal, but is the least electronegative nonmetal on the periodic table to form a polar covalent bond, all right? So what we'll be taking a look at is we need to make sure to give our nonmetal and hydrogen characters names. Again, remember, make sure to make up first names, but their last name should actually be the name of the nonmetal or the hydrogen, right? So my example here is bromine. Do not copy because you weren't allowed to use bromine. Okay, so you can see I gave it a first name, right, Leon bromine, and then my hydrogen, I gave that one a first name, Kitty hydrogen. All right, so what you're going to go ahead and do is we're going to go ahead and take a look at the tug of war between our nonmetal and our hydrogen characters. And so you need to be able to explain how your nonmetal is stronger than hydrogen. So for example, my bromine is a lion and my hydrogen is a cat. Again, this is a children's story, so you should make up a pretend children's story trait or characteristic. Okay, like that. Okay, so then you're going to go ahead and explain how your nonmetal character tries to share something with your hydrogen character, but the nonmetal ends up getting more just because they're bigger or stronger, that kind of idea. So for example, if they try to share a blanket, like cats might do. And how this still results in friendship though, because obviously since my bromine is bigger or stronger, they need more of the blanket anyways, right, than my hydrogen who's not as big or strong. So they still end up being friends because of the nonmetal trying to share. Just remember that the idea of polar covalent bonds is they don't share perfectly, right? So polar covalent bonds don't share perfectly. So again, this is an analogy for how this is like a polar covalent bond. And you can see here that we have an unequal sharing of electrons, right? So the one that's more electronegative is going to, which will be your nonmetal, attracts electrons more, making it partially negative, whereas the less electronegative, which is the hydrogen, nonmetal, attracts electrons less, which makes it partially positive. All right, so that'll be important for later when you do your analysis. So I would make sure to write this down or take a note of this because this is really important. All right, so let's go ahead and take a look at our actual story. Again, you don't need to actually write anything on slide 13. This is just instructions. So now taking a look at slide 14, this is where you actually do your story. So you say, once upon a time, there was a nonmetal named. Again, this is your nonmetal from slide number 3. Again, make up their first name. It can be a different first name than your other stories, but their last name should be the actual element. Okay. Explain again how they're either bigger or stronger or along those lines of somehow they're a little bit better at something than the hydrogen. And then over here was another element named, again, make up a first name. Their last name in this case should just be hydrogen, so we know that it's a hydrogen, and explain how they're not as big or as strong. Again, my example was the lion and the cat. Okay. Then you're going to go ahead and type how your nonmetal, the bigger, stronger one, right? So bigger, stronger one, try to share something with the hydrogen who is smaller or not as strong. Again, make sure that the object is related to your made-up trait, your pretend trait or characteristic. Make sure it makes sense to the story. Otherwise, I'm going to be like, that doesn't make any sense. All right. But because the nonmetal was so much explain how they're bigger or stronger, they accidentally took too much, right? So they're not great at sharing, but they're still trying to share. So the hydrogen, right, so make sure to type the hydrogen's name, still appreciated the effort, and so they still became best friends. Again, you can still create a bond here. Even though they're not sharing perfectly, there's still an effort to share. Okay, so this is just like a polar covalent bond where two nonmetals share electrons, but one nonmetal attracts the electrons more than the other. So the more electronegative nonmetal who's more attractive to negative electrons, you should be able to figure out if they become slightly positive or slightly negative. Again, I actually already gave you the answer when we were talking about this on slide 13. So if you need to review that, go back to slide number 13 when I was talking about that. But again, more electronegative means that the negative electron friends are closer to this nonmetal. And so if you have negative friends that are closer to you, think about if you become slightly positive or slightly negative. While the less electronegative nonmetal, right, in this case will become slightly positive or slightly negative. This one should be the opposite, right? Because this time the negative electron friends are further from this nonmetal. Okay, so think about yourself. If your negative friends are further away from you, do you become more positive or negative? All right, but they are still bonded through their equal or unequal sharing of electrons. Remember, one of them is more electronegative, so one of them is winning the tug of war. So think about, is that going to be equal sharing or unequal sharing of electrons? Remember, someone is winning or is better at the tug of war on electrons. Okay, so that should help you figure out if that should be equal or unequal sharing. Let me go ahead and just put that there. All right, so at this point you should be able to complete your slide number 14. Go ahead, pause the video, and then we'll go ahead and do the analysis together. Okay, so for slide number 15, you need to go ahead and draw the Lewis dot diagram. This Lewis dot diagram is actually very similar to the one for nonpolar Lewis dot diagrams, the ones that we did with the identical nonmetals, the two identical nonmetals on slide 11. However, this time you do need to show the actual partial charges, because remember, one of them is more electronegative, making it slightly negative. One is less electronegative, making it slightly positive. So you'll go ahead and you'll just draw this on a piece of paper, take a picture, and then make sure you insert that picture here. Okay, so let me go ahead and show you what this looks like. I'm going to give you an example for every single type of nonmetal. So if you chose a group 17 nonmetal, that means that you either chose fluorine or chlorine. Chlorine, okay. This is going to be the diagram that you will be taking a look at. So I'm going to label my nonmetal as Y, just like I've been doing for my other Lewis dot diagrams. Again, please use the real abbreviation for your nonmetal, such as F or Cl, but for my example, I'll just use Y as kind of the generic one, and then hydrogen will be H. Everybody will have hydrogen. So what we're going to go ahead and do is, first step, we're going to go ahead and actually draw these out. So I have my nonmetal Y, and taking a look here, it is in group 17, so that tells me it has 7 valence electrons by looking at that last digit. So I'm going to draw that out. 1, 2, 3, 4, 5, 6, and 7 valence or outermost electrons, and hydrogen over here on the right. Just a reminder that hydrogen only has the smallest shell, which can only fit 2 electrons, and currently it has one of two of those valence electrons. So I'm going to go ahead and draw with hydrogen just 1 valence electron. Now let's go ahead and show you what they look like when they match up. So this electron right here will get shared here. Again, this is sharing. Sorry, this is step number 2, showing the sharing of electrons. And so the arrow should go both ways, right? So unlike an ionic bond where we just transfer an electron one way, in this case this is sharing because it's covalent. All right, so let's go ahead and then draw our final answer here. So step number 3 here, I'm going to draw my nonmetal here, bonded now with my hydrogen. Remember that each shared pair of electrons is drawn in our final answer as one single line. All right, So this shared pair right here just becomes a single line, which I'll go ahead and draw in blue, pink, just to keep it consistent with my hydrogen right here. And don't forget that my nonmetal here still has the other electrons right here, the other 6, okay? Now we do need to go ahead and show those partial charges. Again, it is a polar bond, which means that there are partial charges. Remember that our nonmetal, which is either your fluorine or chlorine, is more electronegative, and therefore it pulls the negative electron friends closer to it, right? So negative electron friends are closer. So if your negative electron friends are closer to you, that means that you are a more negative person. So you need to draw a partial negative charge. So over here on our nonmetal, we're going to go ahead and draw a partial negative charge right here, okay? That backwards loopy D again is a delta, which means partial charge. Our hydrogen, on the other hand, is going to be more electronegative. So hydrogen is more electronegative, and so the negative electron friends are further. And just like in your life, if your friends are further, your negative friends are further away from you, then in that case you would actually become partial positive. So we have a partial positive charge here. So this is what your final diagram should look like, exactly like what you see up here in steps 1, 2, and 3. I am going to check our answers though, just to make sure that everything is stable. So please do not copy what you see in blue. This is just our check, right? So do not copy the blue, okay? So taking a look here, I'm going to go ahead and draw that this nonmetal has 2 electrons on top, 2 electrons on the left, 2 electrons on the bottom, and 2 electrons in the middle for this bond. Remember, it's a pair of electrons. So taking a look here, this nonmetal here, remember, believes that it owns everything in the middle. So 2 plus 2 plus 2 plus these 2 in the middle, this nonmetal believes it has all 8 valence electrons, which does in fact make it happy and stable. That is our octet rule. Now, same thing with our hydrogen, though. Our hydrogen also believes that it owns everything in the middle. So it believes that it also owns these 2 electrons right here for a total of 2 valence electrons, which we said hydrogen can only fit 2 valence electrons. And so this actually also makes hydrogen stable and happy, even though it's not the full octet. Again, it can only actually fit 2. Again, you don't need to copy that. That's just to prove to ourselves that this actually is a stable compound. So again, please do not copy the blue part. But this should be your final answer if you chose a group 17 nonmetal, such as fluorine or chlorine. Let's go ahead and take a look at group 16. So group 16 nonmetal here. This means that you either chose oxygen or sulfur. And we're going to show how they bond with hydrogen. So I'm going to label our nonmetal as just Y to show you the generic version. Again, you should actually use the real abbreviation for your nonmetal, such as O or S, all right? And then everybody will use H for hydrogen because everybody's bonding with hydrogen in this polar covalent bond. So step number 1 is to draw out our nonmetal, which again, I'm going to label as Y, but yours should either be O or S. It is in group 16, which tells me that it has 6 valence electrons. So 1, 2, 3, 4, 5, and 6. And we're going to go ahead and have it bond with hydrogen. Now, if you watched the previous part, you already know that hydrogen only has the smallest shell, which can only fit 2 valence electrons, and currently it only has 1 of 2 of those valence electrons. So I'm going to go ahead and just draw that hydrogen only has 1 valence electron out of its 2 that it wants. We'll check at the end to make sure that it gets the 2 that it wants. Let's go ahead and show how these get shared. All right, so remember, sharing, covalent bonds actually share their electrons, unlike ionic bonds where there's a complete transfer, a one-way transfer. When we share, there needs to be these arrows need to be going in both directions because it's sharing. All right, not a one-way transfer. You will notice, though, that our nonmetal here still has an unpaired electron, so that actually means we need another hydrogen to help fix this. All right, so we'll add a hydrogen down here with its 1 electron, and we'll go ahead and pair those ones up as well, like so. All right, and now that is step number 2, just showing you how the electrons are shared. So step number 3 is to just draw our final answer with our partial charges. So we have our nonmetal right here, and it's going to be bonded with the hydrogen on the right and the hydrogen on the bottom. Remember that every shared pair counts as is drawn as a single line in our final answer. So a shared pair of electrons is drawn as one single line. So right here, this shared pair, which I drew in pink, so I'll keep it consistent, should just be a single line. And this shared pair right here, again, should also just be a single line. And don't forget the nonmetal still has its other 4 valence electrons. So 1, 2 on top, 1, 2 on the left. Okay. Last but not least, we just need to draw partial charges. Remember that our nonmetals, all right, all of our nonmetals except for hydrogen, all of our nonmetals that we chose are going to be more electronegative than hydrogen. So more electronegative means that it attracts those negative electron friends more. So the negative electron friends are closer. And just like in your own life, if you have negative friends that spend more time around you, you actually become more negative. And so over here, this nonmetal right here, your oxygen or your sulfur, should have a partial negative charge. Make sure you draw that kind of weird backwards letter loopy D, delta, to show a partial charge. Your hydrogens, on the other hand, are less electronegative. And so the negative electron friends are further away. And so in this case, because our hydrogen is spending less time around negative friends, each hydrogen actually has a partial positive charge. So this is what your final answer should look like if you chose a group 16 nonmetal. The only other thing we're going to do is make sure that our answer is correct. So please do not copy what's in blue. This is just my check. Do not copy the blue. Okay, so let's go ahead and check that our answer makes sense here. So we have 2 electrons on top, 2 electrons on the left, and 2 from each bond. Remember, each bond is a pair of electrons. So 2 electrons here and 2 electrons here. Now remember that everyone believes that they own the electrons in their bond. So this nonmetal believes it owns the 2 on top, the 2 on the left, as well as the 2 from this bond and the 2 from this bond. So 2 plus 2 plus 2 plus 2. This one believes that it has all 8 valence electrons, and that is a full octet, which means that this nonmetal is happy. Over here we have our hydrogen. All right, our hydrogen also believes that it owns everything from its bond. And so in total, it believes it has 2 valence electrons, which again is not a full octet, but we mentioned that hydrogen can only actually fit 2 electrons. And so this actually does make this hydrogen happy. And you can see the same thing happening over here. This hydrogen believes it owns these 2 electrons and is therefore happy. Again, don't copy what's in blue, but your answer should look pretty identical to what we have up here for everything except for what's in blue. The only difference here is that, again, remember that instead of the letter Y, you should be either using O for oxygen or S for sulfur if you chose a group 16 nonmetal. All right, so if you chose a group 15 nonmetal, that's either nitrogen or phosphorus. And I'm going to be labeling it as the letter Y just because that's how I've been labeling my nonmetals. Again, you should use the real abbreviation for your nonmetal. So you should be using either N or P. All right, and we're going to take a look at how it bonds with hydrogen, all right, in a polar covalent bond. So step number 1, we're going to go ahead and draw out our atoms here. So taking a look here, nitrogen, all right, should be our nonmetal should be drawn here. All right, again, yours instead of Y should either be N for nitrogen or P for phosphorus if you chose a group 15 nonmetal. Taking a look here, we are in group 15, so taking a look at the last digit of that, that tells me that this has 5 valence or outermost electrons. So 1, 2, 3, 4, and 5. And taking a look here, we're going to go ahead and draw out the hydrogen now. So hydrogen, if you've watched the other parts of this video, hydrogen only has the smallest shell, which can only fit 2 valence electrons. So again, this is a little bit different than most of our nonmetals, which can fit 8 valence electrons, the octet rule. And currently hydrogen only has 1 of its 2 valence electrons. So it does eventually want another valence electron. So we're going to go ahead and just draw it with its first valence electron and see if we can get it to have both of its valence electrons through sharing. Now, step number 2, we're going to go ahead and take a look at how these electrons are shared. As a reminder, that when you share electrons instead of just transferring them like an ionic bond, the arrows do need to go both ways. So taking a look here, we're going to go ahead and share this unpaired electron and this unpaired electron back, all right? But you'll notice here that we still have some unpaired electrons here, so we need to go ahead and add some more hydrogen. So I'm going to add another hydrogen down here with its 1 electron, all right? And we're going to go ahead and show this being shared. I'll show this in pink here, all right? So these ones are also being shared. And we still have an unpaired electron right here, so let's go ahead and draw another hydrogen with its 1 electron and show how these are being shared. So let's go ahead and draw that one in green. Okay, all right, so we have all of these shared electrons now. Everybody has a partner, and so now we're going to go ahead and do step number 3, which is just to draw our final answer. Again, whenever we have a shared pair of electrons, that should be drawn as a single line. Shared pair of electrons equals 1 single line. So let's draw that final answer. So we have our nonmetal here, and we have a shared pair of electrons with this hydrogen. Okay, so that'll be drawn as a single line. We have a shared pair of electrons with this hydrogen on the bottom, so that's a single line. And we have a shared pair of electrons with this hydrogen on the left, and so that is a single line. And I just color coordinated them so that you can see those becoming single lines. Now, this is your final answer. Yours should look, oh, sorry, and don't forget these 2 electrons on top for our nonmetal. Oops, let me draw that in the other color. Right here. All right, so this should be this is not quite the final answer. So taking a look here, we do need to do those partial charges. So remember that our nonmetal in the middle is going to be more electronegative. All right, so more electronegative, which means that it is going to attract negative electron friends more. And so the more you attract negative electron friends, that actually is going to make you have a partial negative charge, right? So we're going to go ahead and draw next to our nonmetal here the delta sign, which is kind of like a curly D with a positive sign, or sorry, with a negative sign. Oh my goodness, with a negative sign. All right, each hydrogen on the other hand is less electronegative. And so less electronegative means that negative electron friends are further away, and so if your negative friends are further away, then you feel more positive. So in the same way, all of these hydrogens actually have partial positive charges. So you'll go ahead and draw these as partial positives. All right, so those are those partial charges. So this is what your final diagram should look like. I am going to go ahead and check our answer here and make sure that this makes sense here. So let's go ahead and draw that out. So we have, all right, our hydrogen. Oops, sorry, let me, I'm going to go ahead and say don't copy the blue part. Okay, we're just going to go ahead and check our answers in blue. So taking a look here, this nonmetal believes that it has the 2 electrons on top, as well as the 2 electrons from every single one of these bonds. Remember, each bond here is a pair of electrons. So this is 2 electrons, this is 2 electrons, and this is 2 electrons. So this nonmetal here believes that it owns the 2 on top, as well as the 2 from every bond. This 2, this 2, this 2. So 2 plus 2 plus 2 plus 2. It believes that it has all 8 valence electrons. 8 valence electrons, and is therefore happy, 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 and stable. Now, same thing with each hydrogen. Each hydrogen believes that it owns all 2 electrons in this bond between the nonmetal and the hydrogen. So this hydrogen believes it owns all 2 here. So it thinks it has 2 valence electrons, which remember back here that the smallest shell for hydrogen can actually only fit 2 valence electrons. And again, that kind of breaks the octet rule just because it's not 8. The smallest shell can only fit 2. But in this case, this does mean that its valence shell is full and therefore is happy. That's also true for these other hydrogens here. Again, please don't copy what's in blue. You only need to copy the other stuff. Again, your diagram, though, should look identical to what is up here. The only difference being that instead of the Y, you should have your actual symbol, the N or the P for nitrogen or phosphorus. Okay, so make sure that that picture gets inserted into this slide. We're going to go ahead and move on to just our final analysis here of what was your nonmetal. Again, your nonmetal is whatever you chose on slide number 3, so either group 17 fluorine chlorine, group 16 oxygen sulfur, or group 15 nitrogen phosphorus. So just type in that name here. and talk about how many valence electrons does your nonmetal want to gain. Remember that if you're in group 17, right, you have 7 valence electrons and you want 1 more. If you're in group 16, you have 6 valence electrons and you want 2 more to get to a total of 8, that full octet. And if you're in group 15, you have 5 valence electrons and you want 3 more to get to a full octet, to get to a full 8. All right, so that should help you figure this out right here for how many yours wants to gain. Either it wants to gain 1 more, 2 more, or 3 more, depending on what group you were, right? Group 17 was fluorine, chlorine. Group 16 was oxygen, sulfur. Group 15 was nitrogen or phosphorus. Okay. Hydrogen is also a nonmetal. Hydrogen, we talked about how many valence electrons does hydrogen want to gain. Remember, hydrogen only has the smallest shell that can only fit 2 valence electrons. Valence electrons in order to be happy stable. Hydrogen currently has 1 of 2, which means that, or 1 of those 2 valence electrons has 1, which means that it wants 1 more. Okay, so everybody's answer here should be that each hydrogen here wants 1 more valence electron, which we saw in our diagram. So if you have 1 atom of your nonmetal, how many hydrogen atoms did you need to share electrons to make your nonmetal stable or happy? We saw that in our Lewis dot diagram. So we saw that if you were in group 17, because you just needed 1 more valence electron, that meant that you only needed 1 hydrogen. If you were in group 16, you needed 2 more valence electrons, which means that you needed 2 hydrogens in total. And if you were in group 15, you saw that we ended up drawing 3 hydrogens. You needed 3 hydrogens in total, okay? So that should help you figure out what to put in here, all right? And finally, you just need to write the chemical formula. So again, you will leave this as H, right? So leave this as hydrogen, H, all right? And just draw out the number here. So this, if you were in group 17, this should be a 1. Or a blank. You don't have to draw a 1. You can just leave it blank. If you were in group 16, this should be 2 hydrogens, so put a 2 here. If you were in group 15, then you needed 3, so put a 3 here. All right, your nonmetal, put in the actual abbreviation for your nonmetal, which should either be fluorine, chlorine, oxygen, sulfur, nitrogen, or phosphorus. So don't leave it as a letter N unless you had N for nitrogen, right? The N here just stands for your nonmetal. And then in this case, everybody only should have 1 nonmetal here, so you can go ahead and just leave this as a 1 or as a blank. So leave it as a 1 or blank means 1 as well. So you can just delete that if you want to. All right, to double check your answer, you can always go to ptable.com and look at the compounds section. So let me go ahead and show you what that looks like. So if you go to ptable.com, go to the compounds area, all right, and just drag in your nonmetal with your hydrogen. So my example here, again, is don't copy mine because you weren't allowed to choose bromine. But in my story, for example, I used bromine and with hydrogen here. So if you take a look here, the compound that contains both hydrogen and bromine, you can see is just H1Br1. So H with a blank means 1, Br with a blank means 1, so I needed 1 hydrogen for 1 bromine, which makes sense based on what we talked about because it is in group 17. Okay, 17 only needs 1 more electron, so we only need 1 hydrogen. All right, so again, you can use that to actually check your answer here, all right, but instead of using bromine, you can go ahead and put in your fluorine, chlorine, oxygen, sulfur, nitrogen, or phosphorus, and take a look at what its chemical formula should actually be and double check your answer here. So that's an easy way to make sure you have the right answer. Slide 17 is just a reflection. Tell me what's something that went well. Please don't say, I don't know, I don't care, IDK, IDC, nothing, everything. Those are not acceptable answers. Please be specific about something that went well. Thanks so much, everyone, and that's all you need for this last section.